Today's lesson is on arithmetic, sequences, and series. We're looking at patterns. Arithmetic are linear patterns. So a sequence is a list of numbers in a particular order. Each number in the sequence is called a term. A1 is the first term, A2 is the second term, and we use AN to represent the nth term. A term we're interested in finding, a term we don't know, or to write the rule for the arithmetic sequence. An arithmetic sequence is a sequence in which each term after the first is found by adding a constant called a common difference, D. So the pattern for a arithmetic sequence is adding the same number over and over and over again. And it has to be the same number every time, a common difference, in order for it to be arithmetic. There are other sequences that don't qualify as arithmetic. They might add 1 and then add 2 and then add 3. So we're looking just today at the arithmetic ones. So find the next 4 terms of the arithmetic sequence. -8, -6, -4. Basically, can you continue the pattern? Now this set of notes is going to be a little bit different than notes we've done in the past. I have my example, and what you should be writing down in your notes as you're watching this video is your example. Pause it, write the problem down, and as I do my example, and then you do your example in your notes. You're not meant to write down my example. You're meant to work through your example after you watch me do mine, so that your notes are comprised of you practicing what you just saw. So, what is the pattern that you notice here for -8, -6, -4? Well, we can find the common difference by subtracting the second term from the first term, subtracting the third term minus the second term, or you should notice that this is just adding 2 every time, +2, +2. +2. So the next term would be -2, and then we're going to add 2 to -2 and I get 0, and then we add 2 and get 2, and we add 2 to get 4. Those are my next 4 terms. This would be called A1, A2, A3, A4, A5, A6, A7. Find the next 4 terms of your sequence. Pause the video, write down your example, and find your next 4 terms. Okay, you should have gotten +3 every time, 12, 15, 18, and 21. So the next example, find A10. Now, normally this would look like A with a little 10, a subscript. But when I converted this into the Explain Everything app, it did not keep my subscripts. So find A10. That means find the 10th term. So this is A1, -17. A2 is -13. A3 is -9. So I need to continue the pattern until I have the 10th term. So it looks to me, -17 plus what gives me -13? A +4, +4. So we're going to go -9 plus 4 gives me the next term, -5. So that's A4. +4 gives me a 5, which is -1. +4 again gives me a 6, 3. A7 +4 from that, 7. A8, 7 plus 3 is, it's +4, so 11. 7 plus 4 is 11. A9, 11 plus 4, 15, and A10, 15 plus 4 is 19. So take a second and pause the video and find A8 4, 7, 16, 25. Continue that pattern until you find the 8th term. Remember, that really should be written with a subscript because my PowerPoint did not convert in here very well. Okay, you should have gotten A8 equals 70. If you didn't, go back and recount and try that again. Now here the common difference, D, is 9. That's the number we're adding every single time. If it's subtraction, then we call the common difference a negative number if we see it going down. For my example, my common difference, D, was 4. Now we have an equation that allows us to find any term without having to list them all out. As we saw, it's kind of a lot of work to do 8 times and 10 times. So our equation is that an, any term n, is equal to a1, the first term, plus n minus 1. That's the number of terms you're interested in. You want to find the 10th term, then n is 10. 10 minus 1 times the common difference, D. So we can write a rule for these sequences that we looked at earlier. We can also find an indicated term. So here we're going to write the rule which is an equation that allows us to put in any number we want. If I want a 25, I can plug in 25 to the equation and not have to try to solve it all out. So remember, you're watching me do this problem, and then you're doing the 3, 6, 9 problem on your own. My A1 here is -8. And we saw my common difference here is adding 2. So D is 2. Now when I write a rule, I leave n and n, just like we leave x and y in an equation for a linear equation. We leave x and y, we leave n and an here. So an, any term, is -8 plus n minus 1 times 2. And now I can simplify that by distributing the 2 to n minus 2. So an equals -10. -8 minus 2 is -10 plus 2n. And then if I wanted to find the 17th term, I'm just saying find A17. I can plug that into the equation. -10 plus 2 times 17. -10 plus 34 is 24. So A17 is 24. And you'll be asked to do that in the homework tonight, to write the rule and then find that term number that they ask for. So go ahead and try 3, 6, 9. What is your A1? What is your D? And then after you write your equation, find A20. Okay, you should have an answer now. Your A1 is 3, your D is 3. Your AN equation should be 3n. If you didn't get 3n, go back and look at how you plug the numbers in. Distribute your 3 and see if you get that. And then A20 is 3 times 20, which is 60. So your A20 is 60. I'm not solving for that 20. I'm saying the 20th term is 60. Now, it says find the indicated term. It tells me what A1 is. Remember, that's a little subscript when you write it in your notes. D is -9 and n is 20. So AN is -4 plus n. I want to find the 20th. Let's actually replace that n with a 20 because I want to find A20. It doesn't ask me to write the rule, so I can just plug in the number that I'm interested in and multiply that by the common difference. Remember, our equation is A1 plus n minus 1 times D. I get -4 plus, let's use the order of operations here to make our life easier. There's no reason to distribute. We get 20 minus 1 is 19 times negative 9. 19 times 9 is 171. So negative 4 plus, sorry, not plus, minus 171 is negative 175. That's the 20th term if the first term is negative 4 and the common difference is negative 9. So a common difference of negative means you're subtracting repeatedly. But we always think of it in terms of plus for adding and negative for subtracting. So go ahead and take a second, find the 15th term, A15, if your A1 is negative 4 and your D is 5. Pause the video. Okay, if you have not worked it out on your own, you're pausing the video before you look for the answer. A15 should be 66. If you didn't get 66, go back and check your work. Did you subtract your 15 minus 1 first, then multiply by the 5? Remember, you're now subtracting because you have opposite signs, negative 4 and 70. More writing a rule. Write the rule for the nth term of the sequence, then graph the first 6 terms of the sequence. So here, I'm given A13 equals 42, and that should be written with a subscript, and D equals 42. So I don't have my A1, but I can find it by using my equation. Remember, my equation is AN equals A1 plus N minus 1 times D. When I'm given A13, that tells me that N is 13, and when N is 13, AN is 42. So the 42 goes in for the AN. 42 equals A1. I don't know A1, so that's my variable. Plus N, I know N is 13, minus 1, and it tells me D is 4. So 42 equals A1. 13 minus 1 is 12, times 4 is 48. Subtract 48. And A1 is negative 6. Now that I know A1, I can write a rule. AN equals negative 6 plus N minus 1 times 4. My D is 4. That's negative 6 plus 4N minus 4. And AN equals negative 10 plus 4N. And when we graph these, we are graphing discrete points. You can't have a 1.5 term. You can only have a term 1, term 2, term 3. And so our graphs are individual points. This one starts at negative 10. Okay, and I have 1, 2, 3, 4. Negative 10 ends up being my 0th term. When I plug in 1, my first term, negative 10 plus 4 times 1, negative 10 plus 4 is negative 6. So my first term, 1, 2, 3, 4, 5, 6, is negative 6. And then we're going to add 4 every time. So term 2, negative 6 plus 4 is negative 2. And I can plug in 2 if I wanted, right? But we know that's kind of like a slope, up 4 over 1. We just don't connect them. So negative 2 plus 4 is positive 2. So that's the third term. The fourth term, 2 plus 4 is 6. 1, 2, 3, 4 more. And the fifth term is 6 plus 4 is 10. And it says to graph the first 6 terms, so 1 more. 1, 2, 3, 4, 14. I do not connect them. I do not connect the points. They are individual values because there is no in between. It's either the first term or the second term. There's no half term. This is called a discrete function, a discrete graph. Okay. Can you pause the video and do the second example. If A15 is negative 35 and D is negative 3, can you find the equation? First, find A1. Plug in what you know. Pause the video and work it out. If you haven't done it yet, you need to pause the video and try it on your own. I'm going to do this one with you, show you how to do it, to make sure you can check your work and see what you did wrong. So that means my AN is negative 35 and my N is 15. So negative 35 equals A1 plus 15 minus 1 times my D, which it says is negative 3. Negative 35 equals A1 plus 14 times negative 3. Negative 35 equals A1 plus, that's 30 plus 12, negative 42. We will add 42 to both sides, and A1 equals 7. So my rule for any term n is 7 plus n minus 1 times negative 3, which is 7 minus 3n plus 3. So AN equals 10 minus 3n. And so for the graph, our first term, 10 minus 3 times 1 is 7. So 1, 2, 3, 4, 5, 6, 7, 1, 7. Term 1 is 7. And then we're going to subtract 3 every time. Term 2, 1, 2, 3, negative 4. Term 3, negative 1. 1, 2, negative 1 minus 3 is negative 2. So term 4 is negative 2. Term 5 is negative 5. And term 6 is negative, I think I'm at 8, negative 8. And remember, we don't connect the points. Okay, what if we know two terms and we want to know the rule? Well, our equation, AN, A1 plus n minus 1 times D. If we have 2 points on a line, we can find the slope, we can find the equation. It's a similar process. We're going to plug in what we know. If I say A12 equals 87, that means the AN is 87 plus A1. We're not given A1. I'm sorry, not plus, equals A1 plus the N is 12 minus 1 times D. I don't know A1 or D, but there's my A1 N, and there's my AN. Then I can write an equation for A4. 31 equals A1 plus 4 minus 1 times D. Well, I can simplify. 87 equals A1 plus 11D, and 31 equals A1 plus 3D. So I have 2 equations with 2 variables. System of equations, let's use elimination. It's a lot easier than substitution. Multiply by a negative 1, and we get negative 31 equals negative A1 minus 3D. We always want to try to eliminate the A1 because it's never going to have a coefficient. So all we have to do is multiply one of the equations by a negative, add it together, we get 56 equals 11 minus 3. The A1's cancel. 11 minus 3 is 8D, and D equals 7. Now I know D. I can plug it into either of my 2 equations. 31 equals A1 plus 3 times 7. 31 equals A1 plus 21 minus 21. 10 equals A1. And then I can write my rule. AN equals 10 plus n minus 1. I found my D was 7. 10 plus 7n minus 7. 3 plus 7n equals my AN. Now, when we want to take a sequence and add up all those terms, it's called a series. Now, before we look at the formula, I would like you to try to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Add that without a calculator. Take a second. Some people will add 1 plus 2 and then add 3 and then add 4 and then add 5. Some people will find pairs of 10 and add those up, or pairs of 5. Others might see 1 plus 10 is 11. 2 plus 9 is 11. 3 plus 8 is 11. 4 plus 7, 11. 6 plus 5, 11. I have 1, 2, 3, 4, 5 11s. And this is where our formula comes from. The formula says the number of terms divided by 2. We had n was 10 in our little thing example here. We had 10 numbers. 10 divided by 2 is 5. And when I add the first term and the last term, I got 11. That was 1 plus 10. I add 5 times 11, gave me 55. Okay, that's where our formula comes from. So it's the number of terms divided by 2 times the first term plus the last term. And Sn means the sum of n terms. Okay, so when we say S30, that's asking for the sum of 30 terms. Okay. So a series is when we are adding them up. An arithmetic series is adding up the terms of an arithmetic sequence where we're adding the same number every time. So find the sum of the first 20 even numbers starting with 2. Well, first 20 even numbers, that's 2, 4, 6, 8, all the way to 40. 40 would be the 20th even number. So I have 20 terms. N is 20. My first term is 2. My last term, a 20 in this case, is 40. And so the sum of the first 20 even numbers is 20 divided by 2 times 2 plus 40. So that's 10 times 42. The sum of the first 20 even numbers is 420. Now your example is to write out the first 18 odd numbers starting with 1. So go ahead and write them out. See if you can figure out what that 18th odd number is. Give it a try before you continue watching. So pause the video. Okay, you should have had a chance to do this on your own by now. Let's go 1, 3, 5, 7, 9, 11. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the first 9 odd numbers. 19, 21, 22, 23, 25, 27, 29, 31, 35, 33, and 35. Okay, so my first odd number, my A1 is 1, and my A18 is the 35th number, is 35, not the 35th number. The 18th number is 35. So I have 18 as my n divided by 2, n divided by 2, my first term plus my last term, 35. That's 9 times 36. $324 is what we should have gotten. Then we have sigma notation. Sigma notation is a concise way of writing a sum using the Greek letter sigma. Sigma, this Greek letter here, capital, is used to represent sum. Lowercase sigma, which did not come into my PowerPoint here, is this shape, and it is used for standard deviation and variance in statistics. So uppercase sigma means sum. The number on the bottom is the term you're going to start with, so you plug in 1 to get the first term. And then the top is what you're going to end with. 10, you plug in 10. So that would be the last term, 30. And then n would be how many terms there are from the bottom to the top number. So the series that is described by this notation is 3 times 1, first I is 1, so 3 plus 3 times 2 is 6, plus 3 times 3 is 9, 12, plus 15, plus 18, plus 21, plus 24, 27, and 30. I stopped when I plugged in 10, right? 3 times 10 is 30. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. 10 terms. Now, if I doesn't start with 1, if your initial value doesn't start with 1, we're going to subtract 10, the top number, minus the bottom number, and then we're going to add 1. Because notice we have 10 terms here, not 9 terms. So you have to actually include the number on the bottom. And what is the sum of this series? Well, our sum formula says n 10 over 2, first term plus the last term. So that's 5 times 36, which is 180. So the sum equals 180. Let's look at another example. Sometimes it uses k. Some of the worksheets use n, which I don't like. It can be very confusing. You can change it to k or I. So this sum here starts with a k of 3 and ends at 10. So we are not going to actually list them all out like we did on the last term. I only need my first term and my last term. So I'm going to plug in 3 to find my A1. 2 times 3 plus 1 is 6 plus 1, which equals 7. And to find my AN, I'm going to plug in the number on top, 2 times 10 plus 1, which is 20 plus 1, 21. So my top term is what I plug in to find AN, and my bottom term is what I plug in to find A1. Now, how many numbers are there from 3 to 10? Sometimes I just like to count on my fingers. Start with 3, 4, 5, 6, 7, 8, 9, 10. I get 8, right? We said if you take n minus the bottom, the top number 10 minus the bottom 3, and then add 1. 7 plus 1 is 8 terms. So n equals 8. So 8 divided by 2 times 7 plus 21, 4 times 28 gives me 112. So that's my answer. I want you to take a second and try this problem. Plug in k equals 2 to find A1. Plug in k equals 6 to find AN. So we find A1, we find AN, and then we find n. Then we plug it into our formula. N over 2, A1 plus AN. Okay. You should have paused it and done the problem by now. I get 3 times 2 minus 4. 6 minus 4 is 2. 3 times 6, plug in the top number. Okay, we're plugging in this here, and we're plugging in this here to find A1 and AN. So 3 times 6 minus 4 is 18 minus 4, 14. And then how many numbers from 2 to 6? 6 minus 2 plus 1. which is 4 plus 1 equals 5. Now 5 over 2 times a1 is 2 plus 14. So I get 5 over 2 times 16. Now, you can make 5 over 2 2.5, or we can use what we learned last chapter about multiplying and dividing fractions. 2 can go into 16 8 times, and then 5 times 8 is 40. That's how we would do it without a calculator. Now, if I'm given the sum, can I find the first 3 terms of the arithmetic series? I know a1 is 9, an is 105, and the sum is 741. So now we are working with both equations. An equals a1 plus n minus 1 times d, and Sn is n over 2, a1 plus an. So we're going to plug in what we know to both equations and then see what we can do. Okay, we have, let's see, an is 105. 105 equals a1 9 plus n minus 1 times d. I don't know n and I don't know d. Now I know the sum, Sn is 741. I don't know n. And I know a1 is 9 and an is 105. So which equation do I have one variable that I can solve for? The second one. I can solve for n. So 741 equals n over 2. 9 plus 105 is 114. Now I can divide the 114 into the 2, or I can multiply 2 times 741. I find this easier. 114 divided by 2. I'm messing up on my calculator here. It's 57. So 57n equals 741. Divide by 57. N equals 13. Now I can plug that in up here and solve for d. So 105 equals 9 plus 13 minus 1 times d. 105 equals 9 plus 12d minus 9 is 96 equals 12d, and divide by 12, so d equals 6. And now I can write my equation. An equals a1, we found was 9, plus n minus 1 times the common difference of 6. 6n minus 6 equals an. 9 minus 6 is 3 plus 6n. So we have to use both equations sometimes. Sometimes we're given different pieces of information. I like to plug everything into both equations and see which one can I solve. And if I have 2 variables and 2 equations, I might need to use a system of equations. All right, let's look at the second example. A1 is 14. An is 29. We really should be writing it A1 and AN and SN. Okay, use the subscripts. Don't write it the way it's written here. So again, plug them into both sets of equations. AN 29 equals A1 14 plus n minus 1 times d. And SN 129 equals n over 2 times 14 plus 29. 14 plus 29 is 3, carry the 1, 43. Well, 2 doesn't go into 43 evenly, so I have the option of dividing it and leaving it as a decimal, or if I don't want decimals, I multiply both sides by the 2, and 129 times 2. Okay, it's 2 ways to solve the same type of equation. 258 equals 43n. Divide by 43. I get n equals 6. Then I can plug that back into the first equation I plugged it into to find D. 29 equals 14 plus 6 minus 1 times D. 29 equals 14 plus 5D. And that's 15 equals 5D, and D equals 3. So then we can write our equation AN equals A1, 14 plus n minus 1 times 3. AN equals 14 plus 3n minus 3. So AN equals 11 plus 3n.